Hi, Mrs. Opponent here, and today we're going to look at arithmetic operations and significant figures. And we're going to start with products and quotients, which is a fancy way of saying multiplication and division. When you multiply two measured numbers, and please remember we are dealing with measured numbers today. So sig figs apply to measured numbers. When multiplying or dividing measured numbers, the number or the final result, the answer, cannot have more significant digits than the term with the least number of significant figures or digits. And a simple example, if we took 25.2 and multiplied it by 2.543, our calculator yields this big long number right here. And the rule is your answer cannot have more sig figs than the term with the least number. So which of these terms has the least amount? Well, this one has 3 sig figs. So in order to multiply and divide sig figs, you need to know how to count sig figs to begin with. So this number has 3. This number has 4. Well, obviously the term with the least number is this one right here. It only has 3, which means your answer can also only have 3 significant digits. So we actually can only report it to 3 digits, which means we have to round this 0 up because of the 8 over here. That becomes 64.1. So the rule with multiplication and division is the term with the least number. Doesn't matter how many decimals it has or what's going on there. It's just the total number of sig figs. The term with the least number determines how many significant digits are in your final answer. For addition and subtraction, the rule is very, very different. It's the number of decimal places that's what is important. The answer cannot have more decimal places than the term with the least number. So for example, if you were to take 25.331 and add it to 1.33, your calculator would give you 26.661. The problem with this is the answer cannot have more decimal places than the term with the least number. So how many decimal places does this number have? 3. How many decimal places does this number have? Only 2. That means your final number can only have 2 decimal places. Your answer cannot be any more accurate than your least accurate measurement. That's a rule of thumb for significant figures, which means we're going to have to round this to 2 decimal places. And it's fine as it is, 26.66. So this will be your final answer. This has more total significant digits than this measurement, but that's because we are doing addition and subtraction. It's only the decimal point that matters in addition and subtraction. When multiplying and dividing, it's the total number of sig figs that's important. And these are 2 rules that are very, very easy to mix up. So we have to practice with them and kind of get them down. So here we have some sample problems, and we'll do them step by step. The first one, if you were to put 1247 plus 134.5 plus 450 plus 78, your calculator would give you 1909.5. And this is an addition problem, and what do we have to do in addition? Well, the answer cannot have more decimal places than the term with the least number. Well, which term has the least number of decimal places? Well, this one has 0 decimal places. This one has 1. This one has 0. This one has 0. So guess what? Our final answer cannot have any decimal places because these terms have 0. So we're going to have to round this. 1909.5 should round up to 1910. And that's exactly what happens. 1910 would be your final answer. In the next case, if you were to add these 4 numbers together, put them all in your calculator. Before we do that, this has 3 decimal places. This one has 1. This one has 4. And this one has 2. And we know the rule is the answer cannot have more decimal places than the term with the least number. So 1 is the least number, so my final answer can only have 1 decimal point in it. And of course your calculator tells you 261.229, so we have to round this. We have to kind of essentially cut this off. So 261.2 is your final answer to that question. So it's the same for addition and subtraction. It is the number of decimal places that is the most important. And now we're going to do a couple products and quotients. If you were to take 2.5 and multiply it by 3.42, your calculator spits out this number. And what's the rule for multiplication and division? The answer cannot have more sig figs than the term with the least number. Decimals don't matter in this case. It's just the total number of sig figs. This one has 2, and this has 3 significant digits. Well, your answer cannot have more sig figs than the term with the least number, so my answer can only have 2 significant digits, which means I need to round that to 8.6. We got to get rid of this one, but we have to round the 5 up to 8.6, so we have to remember our rounding rules when we're dealing with sig figs. If we have 3.10 times 4.520, calculator gives us this as an answer, 14.012. But what is the rule for multiplication? The answer cannot have more sig figs than the term with the least number. So this has 3. That 0 at the end is significant, otherwise we would not write it. Just as this one is significant, otherwise we wouldn't put it there, because why would we need to? Why should we? We're lazy. This number has 4. Which means my final answer can only have 3 significant digits. And what that essentially means is I'm going to simply cut this off. And I have to include that 0 because it is significant. So we have to include that 0.0. It is very significant. If we were to divide these two numbers in scientific notation, this is a small number to the -4th divided by an even smaller number. When we put that in our calculator, if we do it out, we end up with a very long, very large number. Large in terms of how many decimals we have. And if we look at these numbers, this one only has 3 sig figs. This one has 4 significant digits. Again, we wouldn't put the 0 in if we didn't need to. It's there for a reason, to let you know that the measurement is accurate to that level of precision. What is the rule for multiplication and division? The term with the least number of sig figs is how many you can have in the answer. So we can only have 3 significant digits in our answer. So essentially we got to get rid of all of these. We're only allowed 3 digits, and because of this 5 here, we're going to have to round that up to 114. And that's exactly what happens in this problem. That's your final answer. So these rules for sig figs are very easy to mix up in terms of addition and subtraction and multiplication and division. If you had, and this bottom one's sort of a trick question, the number of tables in my classroom times the width of my desk. The trick here is that the number of tables in the room is not a measured number. It's a known number. When you count something, you know that number for certain. It's not the same as a measured number with 1 digit of uncertainty. I can count the number of tables in my room perfectly, and that number is accurate to as many sig figs as you need it to. So please don't forget the difference between measured and known numbers. Measured, you get them with a ruler, thermometer. If you're counting or definitional, 12 eggs in a dozen, those are known numbers. Sig fig rules don't apply to them. So it's only to measured numbers. Always, when we're doing sig figs, we're dealing with measured numbers, and we have our 2 rules. Easy to mix up again, so do some problems with them, and hopefully that helps you, Mr. Spoon.